All right, now we have the integral of 2x cubed plus 1 to the 4th power times 6x squared dx. And notice you're going to have to use substitution here. It's not unless you like raising something to the 4th power, which means not distributing an exponent, but multiplying by itself 4 times. And then distributing. That would be hard. Much easier would just be using a u to u substitution. Right? So u, oops, that's supposed to be a yellow. There we go. U is going to be the function raised to the power. That's going to be a little hint there. And then, of course, du would be its derivative. All right, so let's make u the 2x cubed plus 1, and then the derivative of u with respect to x would be 6x squared. And then, of course, derivative of 1 is 0, and then we can move the dx to the other side. Multiply both sides by dx. So du is 6x squared dx. So this will be replaced with the du, and this will be replaced with the u, and the only thing that's left is the 4. So the integral of u to the 4th du, increase the exponent by 1, divide by the same thing. So this would be u to the 5th divided by 5, and then don't forget your c. So that means f of x is 2x, I don't know why I put parentheses there, 2x cubed plus 1 to the 5th power divided by 5 plus c. And we can always do a check. Take the derivative. F prime of x equals, the derivative of blop to the 5th power would be 5 blop to the 4th power. And you still have that divided by 5 there. And then times the derivative of the blop, which was 2x cubed plus 1. So that would be, the 5's would cancel. You'd have 2x cubed plus 1 to the 4th power, and then the derivative of 2x cubed is 6x squared. And so you see, that checks out, which makes this the integral. All right, so when we integrate, this function is the result. Right? So that's who has 2x cubed plus 1 to the 4th power, 6x squared as their derivative. All right, let's try the next one. All right, so we got a something to a power. Something to the power is going to be the u. So u will be, so this is the same as -2, right? So let's just make that u. When we change it, we'll rewrite that as a negative, the exponent is a -2. But the u is the inside part. X squared plus 6x. The derivative would be 2x plus 6. All right? Now let's multiply both sides by dx. And then we look and we go, hey, we don't have a 2x plus 6. We have an x plus 3. Well, what if we factor out a 2? Right? If we divide those two terms by 2, we have an x plus 3. All you got to do is divide both sides by 2. All right? So we can have a constant that gets canceled out. So 1/2 du will equal x plus 3 dx. All right, so we'll replace all of this with the du, and we'll replace this with the u. So that gives us the integral of, and then we'll put the 1/2 outside. Oh, actually, we're replacing the x plus 3 dx with 1/2 du. So we have 1/2 times the integral of x squared plus 6x to the -2 power. Right, so now we will integrate. Right? And so that would give us 1/2, oh, excuse me, 1/2 u du. All right, let's try it again. 1/2 integral of u to the -1/2 du. Let's just heck with the integrating. We'll just go right to the substituting. We ended up with the same thing. All right, so now let's integrate and substitute. I mean it this time. 1/2 u, so we're going to increase the -2 by 1, so that would be -1, and we'll divide by the same thing, plus c. All right, and so now let's do the substitution. F of x equals -1/2, so let's just put that negative in front there. And then everything else will go down to the denominator, right? So we have the 2 in the denominator and the u to the -1 power. So that's just going to be x squared plus 6x, oops, in the denominator. Plus c. All right, so f of x equals -1 divided by 2 times x squared plus 6x plus c. Let's take the derivative, see if we're right. Let's check. So f prime of x equals, actually before we do that, let's just rewrite that with the negative exponent. F of x equals -1/2 times x squared plus 6x to the -1 power. All right, so now that would be f prime of x equals, we have -1/2 times, the -1 moves in front, times x squared plus 6x to the -2 power, right? So it's the derivative of, it's -1/2 to the blob is -1 times the blob times the derivative of the blob. So the derivative of x squared plus 6x. All right, so that gives us f prime of x equals -1/2, actually now it's a +1/2, times x squared plus 6x to the -2 power. Derivative of x squared plus 6x would be 2x plus 6. If we distribute that 1/2 to both of those, we have x plus 3 in the numerator and x squared plus 6x squared in the denominator. And look, it matches. So our check is good. All right, let's try another one. All right, so here the u will be, I've got to make that yellow. It's hard to see that dark red. The u will be the something to the power, so 3x squared plus 4. Not the power, but just the something that's raised to that power. The derivative with respect to x would be 6x. So now to multiply both sides by 6x, du is 6x dx. Everyone's accounted for. So this part is the u, and this is the du, and the only thing left is the exponent. So we have the integral of u to the 7th power du. We increase by 1, divide by the same thing. So that would be u to the 8th divided by 8 plus c. We'll do the substitute back. So f of x equals, u was 3x squared plus 4 to the 8th power divided by 8 plus c. And there we go. And we can do a check. We would have f prime of x equals, the 8 would move in front, so we have 8 times 3x squared plus 4 to the 7th power divided by 8 times the derivative of 3x squared plus 4. So the 8's would cancel. F prime of x equals 3x squared plus 4 to the 7th power. The derivative of 3x squared plus 4 is 6x. And that's exactly what we have. So this is for certain our answer. Right? Just doing a little integrating here, thanks to substitution. Right? So now u is the something to a power, which is in the radical, so it's to the 1/2 power. So the u is the x cubed plus 1. The derivative of x cubed with, the derivative of x cubed plus 1 with respect to x would be 3x squared. And we don't have, first let's move the dx over. So we'll multiply both sides by dx. So du is 3x squared dx, but there's no 3. Right? So that's okay. Just divide by 3. If you're short a variable, that's a problem. Short a constant, no biggie. Just means it should be on the other side. 1/3 du is equal to x squared dx. So we're replacing this part with a u, this part with a 1/3 du, and then we can integrate. So we have the integral of u, 1/3 times the integral of u to the 1/2 power du. Right? Power rule will increase the exponent by 1, so that would be 3/2. Divide by the same thing, plus c, because this is the indefinite integral. Let's simplify that. 1/3 dividing by 3/2 is the same as multiplying by 2/3. U to the 3/2 plus c. So that would be u to the 3/2 plus c, or u to the 3/2 divided by 6 plus, oh, what am I doing? 2/9. Crazy multiplication there. My head knew what I wanted to write. My hand decided it was going to be it was going to be a 6. No, 2/9 times u to the 3/2 plus c. I have to slow myself down a little bit. Now let's substitute so that we have f of x equals 2/9 times x cubed plus 1 to the 3/2 power. And you can make that the square root of x cubed plus 1 cubed, right? So you could write it, and then plus c. You could write it like what I have above, or you can make it 2/9 times the square root of x cubed plus 1 cubed plus c. Whatever you like, right? They're both the same thing. All right, let's check our work. Of course, I'm going to use the one that has the exponent instead of the radical. So we have 2/9 times x cubed. Actually, I don't have a whole lot of space. So I'm not going to rewrite the equation. I'm just going to start integrating. So, differentiating. F prime of x equals 2/9. And then the 3/2 moves in front. And then we have x cubed plus 1. And then reduced by 1, so that'd be to the 1/2 power. And then times, let's keep writing here, the derivative of x cubed plus 1. So that would be, let's see, the 2's would cancel. This would become a 1/3. Right? So that would be f prime of x equals 1/3 times the square root of x cubed plus 1 times the derivative of x cubed plus 1 would be 3x squared. The 1/3 and the 3 cancel, so that means f prime of x equals x squared times the square root of x cubed plus 1. Right? So you can see why we needed the 1/3, right? The coefficients were canceled out because there was, right, a 2/9 in front. Right? So there was a 2/9. When we took the derivative, right, there went all of our coefficients. And that's why we just had the x squared. Right? Not too hard. Once you get the hang of these, not too hard. This one, you probably look at this and go, what do I do? What do I do with tangent x dx? Now, if I told you to take the derivative of tangent x, no problem, right? Secant squared x. If I told you to take the integral of secant squared x, no problem, tangent x. But who has a derivative of tangent x? Maybe if we rewrite this. So when in doubt, So here's going to be my helpful hint. When in doubt, rewrite trig functions using sine and cosine. All right, so that's going to make this the integral of sine x over cosine x du. Now, could we use substitution? Right, because there's nothing to undo that other than if substitution works. U equals cosine x. Make sure when you've got a quotient, if you have a quotient, actually, let me write that a little lower so I have space for the derivative here. If you have a quotient, still not enough space. And are using substitution, make the denominator u. Maybe not including exponents usually. Here we don't have any exponents. All right, so that means u is cosine x. The derivative of u with respect to x is du dx. Derivative of cosine x is negative sine x. All right, move the dx over, multiply both sides by dx. So we have du equals negative sine x dx. Oops. Well, I guess I knew I was going to use substitution, but can't use a du until I substitute. All right, we see the sine, we see the sine x, we see the dx, we don't see the negative. All right, move the negative over. So negative du equals sine x dx. So this becomes this and this. Become negative du. And then this becomes u. All right, so now we have, right, blue. All right, so we're going to have the integral of negative du all over u. All right, and now we can integrate. All right, so cosine x was replaced with a u. Sine x was replaced with a negative du. And that's our whole integral. We could factor out the negative integral of du u. Hopefully you recognize who this is. This is natural log, right? So this would be negative natural log of u. And we'll put that in absolute value bars because it's got to be positive, plus c. All right, so now let's substitute back. So we have f of x equals negative natural log of u was cosine x plus c. What if we move the exponent back up? All right, so f of x, this is the power rule, right? So we can move the exponent using power rule for logs. So then this becomes natural log of cosine x. We'll put that, keep that in absolute value bars, right, because it has to be positive, to the negative 1 power plus c. All right, well, that's now f of x equals natural log of 1 over cosine x plus c. Right, because if you have something raised to a negative power, it makes it the reciprocal. Well, what could I replace 1 over cosine x with? Who's the reciprocal identity to 1 over cosine x? Right, well, its reciprocal identity is secant. So f of x equals natural log of, and it still has to be in absolute value bars, secant x plus c. And there we go. There's our answer. What? You don't believe me? Want to check it? All right, let's check it on the next page because we don't have a lot of space here. All right, so sometimes you have to get creative with substitution, but let's check it. So natural log secant x plus 3. And I need another page. We can drop those absolute value bars when we're taking the derivative here. Isn't going to make a difference. All right, so f prime of x equals, all right, so for natural log, it's going to be 1 over secant x, right, and then times the derivative of secant x. And of course, the derivative of the c is 0. So f prime of x equals 1 over secant x, the derivative of secant x, tangent x. Oh, look at that. The secant x's cancel. So f prime of x equals tangent x. There we go. There is the check to prove that the derivative of the integral of tangent x is natural log of secant x plus c, and the derivative of natural log secant x plus c is little old tangent x. There you go. All right, so we can be a little creative with substitution. So if you don't see the function you need to use substitution, because we couldn't just find the derivative for tangent x without being able to do substitution, then see if you can rewrite it. Next one we won't have to rewrite, but it is another trig one. All right, so cosine 2x, sine 2x. Let's make u equal to cosine 2x, the derivative du with respect to x. Right, so the derivative of u with respect to x, of course, is du dx. The derivative of cosine 2x would be the derivative of cosine 2x times the derivative of the 2x. So that would be negative sine 2x times the derivative of 2x, so times the 2. I'll put times the derivative of 2x. So that would be du is equal, we'll move the dx over. So du equals negative 2 sine 2x dx. All right, so we see the sine 2x dx, but we don't see the negative 2. No worries, just divide by negative 2. So du is equal to negative 1/2 du is equal to sine 2x dx. There we go. So we'll replace this with u and this with negative 1/2 du. So that gives us negative 1/2 the integral of u and du. That's all we need. U du. All right, so now we integrate. All right, so we're going to increase the exponent by 1. So we have negative 1/2 u squared divided by 2 plus c. All right, now we'll replace it. All right, so that would be, let's simplify first and then we'll replace. All right, so negative 1/4 u squared plus c. All right, so that means f of x equals, u was cosine 2x, negative cosine 2x divided by 4. Oh, and it was squared, plus c. All right, so f of x equals negative cosine squared 2x divided by 4 plus c. Let's check. F prime of x equals, right, so we've got, this one is a chain rule. We've got BLOP squared. So it's going to be the derivative, it's good practicing for taking the derivative. Derivative of BLOP, which is, the negative's not, right, so it'll be times negative. All right, so the negative times the derivative of cosine 2x, that's the BLOP, squared. And actually, let's put the negative and the 1/4 out here. Times the derivative of the BLOP, so that would be the derivative of cosine 2x times the derivative of the 2x part. So this is a chain within a chain within a chain. So f prime of x equals negative 1/4 times the derivative of BLOP squared is 2 BLOP. So 2 times cosine 2x. And then the derivative of cosine 2x is negative sine 2x. And the derivative of the 2x is 2. So that means f prime of x equals, all right, so the negatives will cancel. I've got 2 times 1/4. So that's going to cancel. All right, and it's just going to leave cosine 2x sine 2x. Everything else is canceled out, right? Because 2 times the negative right there times the 2 at the end would give us negative 4. Negative 1/4 times negative 4 is just 1, leaving us cosine 2x sine 2x. So this is correct. That is a correct answer to this integral. But let's try something else. All right, so one answer was so the answer here we got was f of x equals negative cosine squared 2x divided by 4 plus c. Let's make u equal sine 2x. That means du dx equals, right, the derivative of sine 2x would be 2 cosine 2x, and then multiply both sides by dx. So du is 2 cosine 2x dx. I don't see a 2, so 1/2 du equals cosine 2x dx. All right, so now we're going to replace the cosine, this 2x dx part. So this becomes u. This becomes du. 1/2 du. So we have the integral, the 1/2 can go in front. 1/2 times the integral of the u du. And now let's integrate. So we would have 1/2 u squared divided by 2 plus c. Right, that's 1/4 u squared plus c. Let's replace the u, right, with the sine 2x. So f of x equals sine 2x, and that's squared, divided by 4 plus c. Well, that's not the same as the answer that we got here. I got negative cosine 2x divided by 4 plus c. Let's take the derivative and see what we get. All right, so f prime of x equals, right, so the 1/4, no big D. And then we have to take the derivative of the sine 2x squared, right? So that's, I'll put the 2 out there so no one can be confused. Right, so BLOP squared times the derivative of sine 2x, or sine blob, times the derivative of the blob. All right, so this is going to be f prime of x equals, whatever the 1/4, the 2 would move in front, so times 2 sine 2x. Now the derivative of sine 2x would be cosine 2x, and the derivative of the 2x would be times 2. Well, we've got 2 times 2, that's 4. 1/4 of 4 is 1. And those will cancel. And so we have f prime of x is sine 2x cosine 2x. But this one got the same answer. How could that be possible? Well, remember, sine and cosine are the same function, just shifted. Right? This shifted to, the cosine is sine just shifted over. So they're both correct. So they're both of these equations, sine squared 2x divided by 4 plus c, and negative cosine squared 2x divided by 4 plus c, have the exact same derivative, cosine 2x, sine 2x. Right? So it doesn't happen very often. Only sine and cosine can make it happen because they're essentially the exact same equation, just shifted. So which one's right? You pick it. They're both right. All right, let's try this one. Now, a little note. If you can reduce first. We can divide everything by the e to the 2x, which is good because nobody's derivative is there. It doesn't matter what I call u. I don't have the derivative. All right, so if we divide e to the 10x divided by e to the 2x is e to the 8x. You subtract exponents to divide like bases raised to a power. And then plus 2e to divided by, so 2 divided by e to the 2x. And everybody can have a dx. All right, we can rewrite the 2 over e to the 2x as, if we can actually pull the 2 out, put the 2 in front. All right, so we'll pull the 2 out. That's e to the negative, that's the same as e to the negative 2x. Right? It just would be easier to deal with, right, if it's not in the denominator. So here, we're going to do substitution twice. So we can use substitution more than once. If the integral can be split. Here I kind of need it twice. I need it for, I've got x and an exponent in both of them, but two different ones. So no one says it has to be a u. Why can't it be a v? So u is going to be the 8x. And let's just make it w, because my u's and my v's look too much alike. W is going to be the negative 2x. All right, so then du with dx is equal to 8. Right, so let's multiply both sides by dx. So du is 8 dx, but I don't see an 8, so divide. 1/8 du equals dx. So over here, we're going to replace the exponent with a u. We're going to replace the dx with a 1/8 du, but the e stays. On the x part, dw dx is negative 2. Let's multiply both sides by dx, so dw equals negative 2 dx. I don't see a negative 2. Divide both sides by negative 2. So negative 1/2 dw equals dx. So we're going to replace the, oh, never mind, we do have a 2. Huh. We have the 2. Although we would have realized, even if we did not remember we had the 2, it's okay, because the negative 1/2 times 2 would have canceled each other out anyway. but we don't have is the negative. So no point in having extra values. I mean, we get the same answer. We wouldn't be wrong, but we don't have the negative. We definitely don't have the negative. We can leave the 2 there because we do have the 2. So negative dw equals 2dx. All right, so we're going to replace the negative 2x part here with a w and the 2dx with a negative du. All right, or negative dw. And now we can integrate. And it's pretty easy. So we have the integral, let's rewrite it first. The integral of e to the u, or excuse me, 1/8 the integral of e to the u du, right? Because we've replaced the dx with a 1/8 du. And then minus the integral, we've replaced the 2dx with the negative dw. All right, so we don't need the 2, we don't need the dx, but we still have the e to the w dw. All right, so now we can integrate. All right, so we have 1/8 e to the u minus, and we don't need 2 c's, minus e to the w, oh, excuse me, yes, e to the w, it's good, and then plus c. There we go. We got everything in there. All right, so now we took the integral. Now all we got to do is substitute back. We can't leave it like this. F of x equals 1/8 e to the, all right, so that was u was 8 to the was 8x, right? So we'll replace the u with an 8x, and then minus e to the negative 2x plus c. All right, and we've replaced everybody back. All right, and if we took a look here, we'll just talk about the derivative. All right, so if we took the derivative, the 8 would move in front. You'd have 1/8, because you take the derivative of the 8x, right? You'd have 1/8 times e to the 8x times the derivative of 8x, which is 8. The 1/8 and the 8 would cancel, and you would just have the e to the 8x. And if you took the derivative of negative e to the negative 2x, the derivative of e to anything is just e to that power. So it would be negative e to the negative 2x. The derivative of negative 2x is a negative 2. So negative 1 times negative 2 gives you the positive 2 that's there. And that's how we got the 2e to the negative 2x. And there you go. All right, so this is our answer. So you can use more letters, right? Because we needed 1 for the 8x and 1 letter for the negative 2x. And that's where I'm going to stop. All right, so I'm going to stop this one for now, and then I'll see you in the next video. Bye for now.